Hello everyone, the topic of this video is combinations. We are in the middle of a unit on probability and counting techniques. So far we've talked about the fundamental counting principle as well as permutations. So take a look at this problem and see if you can note some similarities and differences to the permutations problems that we've already done. Suppose that after waiting in line overnight you managed to snag the last 3 tickets to a concert. The bad news is that you can only take 2 of your 4 housemates. How many different ways can you choose the 2 friends that get to go? Alright, so think about some of the other problems we've done. Things like take 6 people and arrange them, maybe arrange 4 of them in a line. And then compare that with this problem. We're assuming that the person in the problem is going to the concert, so that means that there are 2 tickets left and they need to choose 2 of the 4 housemates to go along to the concert. So this problem is like 4 people, choose 2 of them. Alright, so what do you see as some obvious similarities? Well, first of all, it's a people problem, it's a counting problem. We're picking people, we're only picking some of them out of the total. Some differences. All right, let's look at repetition. All right, we talked about that as one of the requirements for a permutations problem. All right, we need to make sure that there's actually no repetition. All right, so here again we have a problem dealing with people, so we are also not using repetition. If we choose somebody to stand in line or choose somebody for one of those tickets, then that person won't be repeated for the next ticket or the next spot in line. Okay, so both of these problems don't use repetition. All right, another requirement for permutations problems was that they be uniform, meaning each choice should have no effect on the next choice. All right, so if we think about this problem, let's say you choose person number 1 for the first ticket. Okay, well then how many people do you have left for the second ticket? You have 3. You can choose any of the 3 remaining people. Let's say you choose a different person, number 3. Okay, well how many choices do you have for the next ticket? You still have 3. You have people 1, 2, and 4. Alright, so even though they're different people, the number of options is still unaffected by who was chosen for this first ticket. Alright, so this is a uniform problem. Alright, and then our other requirement for permutations problems was that there be some sort of an arrangement or an order that makes a difference. So when we're arranging people in line, having, let's see, there's 6 people, so maybe like person 3, person 5, person 1, person 6. Okay, that's different than having a different order of those people. Well, what about the ticket situation? If we choose, for instance, 1 and 3 versus 3 and 1, does that make a difference? Well, it doesn't seem to. There's nothing in this problem that indicates any sort of difference in the tickets. It could be, like a backstage pass and one that's regular, but it doesn't mention that. So we're going to assume that there's no difference between who gets which ticket. So that would seem to indicate that this problem actually does not have an order or an arrangement that's necessary. And that is the main difference between permutation problems and what we're now going to call combinations problems. And that is that when you make your selection, it's without regard to order. Right? Without regard to order. And that's called a combination. So some key phrases that you might see to indicate these differences. Okay, P for permutation, C for combination. Permutations will mention, they'll say like arrange or order. For combinations problems, you might see words like choose, select, pick. Okay. And now sometimes you will see those words also in permutations problems, but there will be some sort of an implication or an actual statement that talks about the order. So they might say choose 6 people and put them in a certain order in a line. All right, so choose doesn't necessarily always mean a combination, but it is a good clue. Some examples. Permutations would be things like passwords, okay, where switching the order of numbers or letters makes a difference. Combinations would just be like a group or a selection. Pick a group of letters or a group of numbers. Okay. A permutation would be, let's see, choose first, second, third place for prizes. Combinations would be choose 3 winners. No particular order, just 3 winners. Permutations would be choose a president and a vice president. Combinations would be choose or make a 2-person committee. Right? So we talked about positions or roles like president and vice president as being another way of talking about order, right, where there's a difference between those positions. And combinations, this 2-person committee, there's no hierarchy or difference between those 2 roles, it's just a group of 2 people. Alright, so let's practice. Decide whether or not each of these selections is a permutation or a combination. Right, in A, from a class of 25 students, a group of 5 is chosen to give a presentation. Alright, well that one is a combination. Okay, we're choosing a group of 5 out of 25, but it doesn't mention anything about an order or an arrangement of those people. In part B, a starting pitcher and catcher are picked from a 12-person intramural softball team. Okay, here we do have an order that's implied. Pitcher and catcher, 2 different roles, so choosing people A and B with A as the pitcher is different than choosing A as the catcher and B as the pitcher. So that is a permutations problem. 2 more examples. A 5-digit passcode is chosen from the numbers 0 through 9. That's a password, okay, or a passcode. The arrangement of the numbers would make a difference. You could have 2 different passcodes if you put the same numbers in a different order. So that is a permutation. And then a gardener picks 4 vegetable plants for his garden from 10 choices. So this is picking or choosing 4 out of 10, no arrangement or order that's implied. So this is a combination. Okay, that's an introduction to combinations, what they are, and in the next video we will talk about a formula and a way to actually make calculations of how many combinations exist.